Welcome to this comprehensive watershed delineation tutorial where we will take you through the process of not only delineating one watershed like this, but we will also show you how to delineate multiple sub-catchments like this using QGIS. During this tutorial, we will also address a common issue that some of you guys who are using certain versions of QGIS are facing when running one of the tools that we are going to use in this tutorial, which is called the Upslope Area tool. And we'll go over the process of fixing that issue and getting that tool to work in case if you happen to be one of those who are going to experience that issue along the way. And to sum everything up, we will get the process started absolutely from scratch, which is from the point of obtaining a DEM, talk about stream ordering, and sequentially we will generate the river network from the DEM, generate a watershed, and then go on to generate sub-catchments like this. And finally, we will also perform geometric computations such as calculating the areas of sub-catchments that we generate, all using QGIS. So if that all sounds great, tag along and I assure that you won't be disappointed. Alright, so the very starting point of any catchment delineation exercise using a GIS tool like QGIS is getting hold of a DEM, encompassing the area that you're interested in performing this exercise for. Now I have done a number of tutorials showing you how to download a DEM absolutely for free with no hassle at all from free sources, and I will link the latest instructional video down in the description below for your reference purposes. You can check that out in case if you're not really sure the process of downloading a DEM for free. And in any case, I'll be providing you with the DEM data that I'm using for this tutorial as well. So in case if you want to just use that to follow along and practice your skills, then you're most welcome to do so. So I'm going to navigate into my working folder using the browser panel right over here, which is this folder. And inside that you can see that I have a file called dem.tif. So I'm just going to simply drag this and drop it over here. By the way, this is the file that I'll be providing you guys as well. So you can just simply, before starting this process, you can just simply download it and put it into your working folder. And then you can just start following along. So as soon as you drag and drop the DEM into your workspace, you can see that it gets added to the layer panel. That's the very first thing that you would notice in addition to seeing the actual DEM. And you can see a clear color gradient. And over here, it explains what that gradient refers to. The most darkest colors basically refer to very low elevations, and the lowest being 134 meters and the highest being 4,777 meters. So these very light whitish areas basically refer to those high peaks or those highest elevations. And these darker areas basically refer to the lower elevations, and chances are those very low elevations refer to things like rivers, because naturally water gets accumulated in the lowest areas and that forms things like rivers and drains. And one more thing that you might notice is that this DEM and my workspace has a coordinate reference system which is shown right over here, EPSG 4326, which refers to the WGS 1984 Geographic Coordinate Reference System. So before I actually get started with the process of delineating any catchments, I'm going to do some refinements to my data. And one of those things being, I'm going to cut this DEM out using a defined area because this DEM by itself seems to be pretty large. And if I'm not really keen on delineating any catchments to, let's say, this side of the DEM, then it's just wasted computational power. So what I'm going to do is first, I'm going to figure out where exactly my area of interest is going to be. And based on that, I'm going to define a polygon to sort of mark that boundary. And based on that, I'm going to cut this DEM out. And another thing is that when you're using QGIS for deriving watersheds or multiple watersheds, it's always advised that you first reproject your data into a projected coordinate reference system in case if they happen to be in a geographic coordinate reference system. Now, if I check the properties of my DEM layer and if I head over to information, right over here under coordinate reference systems, you can see it's in EPSG 4326, which is a geographic coordinate reference system. And in case if you're interested in knowing the pixel size of my DEM, you can see that it's merely unreadable because this is given in decimal degrees, so it wouldn't really make sense for us to, well, interpret the pixel size in this kind of very long decimal numbers. So if you actually reproject your DEM before even you get started into a projected coordinate reference system, one of the benefits that you get is that you can actually start using or start measuring things in meters, which is something that we are more or less familiar with compared to, let's say, working with decimal degrees as a unit of measurement, which is not really a practical thing to do. So then it becomes a question, what kind of a projected coordinate reference system you're going to transform your data into. And the chances are you might either know, depending on your geographical location, what kind of a projected coordinate reference system is more suitable to be used. But in case if you are not really sure, one thing that you can do is you can actually use the UTM projected coordinate reference system, which has its units in meters as well. And before I do that, I need to know exactly what kind of a region that I'm working in. And one of the easiest ways of knowing that is actually simply by putting a base map underneath, so that you can actually start seeing things like countries, cities, and towns. So with that, you would be able to see quite easily what kind of a projected coordinate reference system is more appropriate to be used in your particular case. So to add a base map, what I'm going to do is I'm going to head over to my browser panel over here, and if you scroll down a bit under XYZ tiles, you would be able to see a couple of different options like Google Satellite, OpenStreetMap. So I'm just going to drag OpenStreetMap from here and then place it over here. You'll be able to see these options to add Google Satellite and OpenStreetMap, especially in the recent versions of QGIS. And after that, I can just simply move my DEM above this OpenStreetMap layer, and you can basically see the coverage of my DEM. And my area of interest is actually located around this region. And if I turn off the DEM, you can see that that actually falls in the southeastern region of France. So based on this information, what I would do is I would actually take a map where they have defined different UTM zones. And based on this UTM zone map, you can see that my area of interest is actually located in the UTM zone 32 north. So coming back to my QGIS workspace, I'm just going to right click and select export and save as. And from here, I'm going to define a new file name for my reprojected DEM raster. Let's go ahead and name that as DEM UTM32. So in your case, if you're actually following along the tutorial with me, then it's going to be the same case for you as well. But if you're dealing with a different geographic region, then it's always good to refer back to that UTM zone map and figure out what kind of a UTM zone your study area happens to fall in, and select that. So this is where we do the selection, and you can see that the default coordinate reference system is EPSG 4326. So I'm just going to open this up, and the easiest way to basically search for a coordinate reference system is, if you know the EPSG code, you can search based on that, or you can just type in maybe a keyword, something like 32 north, and that's going to basically refine your search in this manner. And this is the one that I'm looking for. So you can see that basically the area that corresponds to this UTM zone happens to fall through the southeastern side of France as well. And that actually provides a further assertion that you're selecting the correct UTM zone for your analysis. And after that, you can just click OK. And we can just go ahead and export this. So now you can see the exported, newly created DEM of UTM zone 32. And I'm just going to get rid of this old DEM for the time being, because I wouldn't really require that anymore. And another thing that you can potentially do is that you can basically change the coordinate reference system of your QGIS workspace or data frame as well, simply by heading over to this button right over here. And you can basically pick the same UTM zone 32 north coordinate reference system as well. Click apply and click OK. And now what I'm going to do is I'm actually going to define my area of interest. And in your case, if you happen to have maybe a polygon or something like that which defines your area of interest, then you can definitely use that. But in my case, I know that my area of interest basically lies around here. So just to get rid of these external parts of the DEM, I'm going to define my area of interest manually using a polygon. And after that, I'm just going to cut this DEM out based on the extent of that area of interest. So that means it actually involves creating a new polygon type domain. And to create a new polygon feature or an object, you can first head over to your working folder and right click, and over here you can select new and select shapefile. And over here you can just define a name. I'm just going to call it domain. And the geometry type, it's quite important. It's going to be polygon. And the coordinate reference system is quite important as well, because especially when you're using a defined polygon to cut another raster layer, you have to make sure that both those layers are in the same coordinate reference system. So you cannot have this in WG's 1984 geographic coordinate reference system and expect to use that to cut this DEM out, because it's in a completely different coordinate reference system. So I'm just going to make sure that we are consistent with the coordinate reference system by selecting UTM zone 32 north for this as well. And after that, select OK. Then you can just double click this domain.shp to add that as an empty layer into your layers panel. And I'm just going to right click over here and go to properties. And I'm going to get rid of the fill color, because when I'm drawing my polygon, I would like to actually see the inside of it as well. So I prefer not to have a fill color, especially when drawing objects. So the way to get rid of your fill color, even before you actually start drawing your object, is simply by selecting this simple fill, and from here you can select just outline. And maybe for the outline color, just select something that stands out from your background, something like yellow maybe. Click apply and click OK. After that, you have to put this domain layer into an editable mode. So the way to do that would be by heading over to this toggle editing tool right over here. You could click on this one, or if you just right click over here, you probably might be able to see that right over here as well. So this puts this layer into sort of an editable mode. And after that, you can pick this add polygon feature button, and then you can actually start drawing your polygons. So I'm just going to define one single polygon just to sort of isolate my area of interest, which happens to fall just around this region. And after that, to conclude, you can just right click once and it'll stop adding vertices, and you can just simply close it like this. So since I'm not going to add any more polygons, so this is just the only polygon that I want to add. And after that, you can just click on this pencil button once more to save your edits. And now it means that you have actually added one record or one feature to this domain layer. And if you open up the attribute table, you'll be able to see that the one record or the one feature that you created. And just to make sure that this layer is also in the same coordinate reference system, what you can do is you can just right click and go to properties, and you can head over to information, and you can just verify that it's in UTM zone 32 north as well, just as my DEM, which means now I'm going to be able to perform a clip operation to clip this DEM based on this boundary defined by the polygon. So you can head over to raster and go to extraction, and you can say clip raster by mask layer. And my input layer is definitely going to be the DEM. And I'm going to mask that based on this domain polygon. And the rest of it, you don't really have to do anything much. Just over here, you could either save it directly into a permanent file, or you could just first generate the output and have a look at it. And then if you're happy, you can just go ahead and save it to a folder of your choice as well. So let's just go ahead and let it save the file to a temporary file first by clicking on this run button. And you can see that the tool ran quite quickly and it generated basically a clipped version of the DM, which means I no longer would be needing this original, well, the transformed UTM-32 large DEM. Now I just have a clipped version of my DEM just like this. And this would be the DEM that I'll be working on from now on. So this one I can just right click over here and go to export and save as. And the format is GeoTIFF, and you can see that the coordinate reference system is UTM zone 32 north as well. And to define the file name, we can just go ahead and type DEM clipped and save it as a new TIFF file, which means we probably won't be needing this temporary file either. So I'm just going to get rid of that. And the original DEM and the domain, well, let's not get rid of it completely, but we can just keep them unticked like this. So with that, we are going to get started with the catchment delineation process. And for that, we are going to make use of a tool called SAGA tools. Now, in the previous versions of QGIS, they used to include a version of SAGA tools by default. So along with every fresh installation, we used to get access to SAGA tools, but they don't really do that any longer. So we have to access SAGA tools as an external plugin nowadays. So now if you want to use SAGA tools, we basically have to install it from the plugins manager, which is not really a difficult task. So I'm going to head over to plugins and click on manage and install plugins. And from here, I'm just going to search for SAGA. And this is the tool that we're going after, Processing SAGA Next Gen Provider. So to install that, all you have to do is just click on install plugin, and that should get installed just in a matter of a couple of seconds. And after that, if you, well, basically open up your processing toolbox, you should be seeing that right over here. So in terms of the catchment delineation, the very first thing that we are supposed to do is we need to perform a fill operation on this DEM. And the reason why we would need to perform such a fill operation on a DEM like this is because in this kind of raw DEMs, there can be usually sinks and peaks that are often errors due to the resolution of the data or rounding of elevations to the nearest integer values and things like that. And when we run a fill operation, it basically fills those sinks and makes sure that the DEM is fit for any drainage basin delineation work. So you can access that fill tool simply by searching for fill over here, and under SAGA Next Gen Tools, you can use this algorithm, which is fill sinks Wang and Liu. So if you double click over here, you can select your, well, the original, well, the clip DEM in this case. And after that, you can just make sure that you save your fill DEM maybe to a permanent file. I'm going to call that fill DEM. And at the same time, I'm not going to, well, generate any of these other files like flow directions or watershed basins just yet. So I'm just going to untick these two, and we'll go ahead and run this tool. And depending on the size of your DEM, it can actually take quite some time. But as you can see, it's pretty quick. Didn't even take a single minute. So now you can see there's a slight difference between the top value of my clipped, well, the original DEM and the fill DEM. So you can see that the number over here is 4769. In this case, it's 4687. So there has been some sort of a correction. And from now on, this is going to be my sort of base DEM that I'm going to rely on for any future operations or analysis. And with that, I'm just going to untick this and just keep it in the layers panel, but probably I might not really make use of this DEM clipped anymore. And following the generation of this filled DEM, the next tool that I'm going to use is called Strahler Order, which is also one of the SAGA tools, but it's quite easy to locate that tool if you were to just use this search box over here. So I'm just going to type Strahler Order, and it's this tool right here, which is under terrain analysis of the SAGA tools. So before we actually start using this tool, I'll give you a quick introduction to what Strahler Order means and why it's going to be relevant for the catchment delineation exercise that we are going to do today. And for that, I would like to refer you to this diagram right here, which is showing a schematic diagram showing how this Strahler stream ordering method should work. So stream ordering is basically a method of assigning a numerical order to links in a stream network, just like this. And this order is basically nothing but a method for identifying and classifying types of streams. As you can see over here, if we consider this yellow color part and this red color part to be sort of a main river branch, all of these are basically tributaries that are joining in. But if you think about the way how this number has been assigned, you can see these smallest tributaries, which are basically the small headwater streams. When two of those join together, it forms a new stream. And as you can see over here, the stream 1 and 1 joins and it creates a new stream, and the order of the new stream is basically 1 unit higher than the order of these smaller streams. And the same phenomena happens right around here as well. Two streams of order 1 joins together and that creates a stream of order 2. And when two streams of order 2 joins together, it basically creates another larger stream with its order being 1 unit higher than the stream order value of the previous two streams, and so on. So you can see that in this example, the same phenomena happens over here as well. And when 2 and 2 join together, it creates a new stream with the order number 3. And similarly, when two streams with the order number 3 joins together, it creates a new stream with the order number 4. Now, something to keep in mind is that when two streams of different order joins together, for example, just like in this case where this small stream of order number 1 is joining this stream of order number 3, but this merging didn't actually influence the stream order of the resulting stream. So even though it happens to be 1 and 3 over here, you can see that the resulting stream still happens to be 3. So it basically takes the highest stream order of the two streams that basically joins together, which happens to be 3 in this case, and it just maintains that. So there's not going to be any change in the stream order whenever this kind of a phenomena happens where a stream with a lower order joins a stream with a higher order. And that's basically true for this case as well. As you can see, the stream that joins this small stream with order number 1 is already a stream with a higher order. In this case, it's 4. And even after these two joining, it didn't really change its order. It just maintained what happened to be the higher stream order of the two. So that's basically how Strahler stream order works. And using the tool that I just discussed, which is the Strahler Order tool, we can basically generate a stream network for the entire DEM, and it can basically point to us which streams are of higher order and which streams are of low order, which can actually help us identify properly what the drainage network or the river network is supposed to be. And that's quite important for our watershed delineation task, because especially when specifying things like outlet points, we need to know exactly where the river is flowing through. And to do that, we need to have a very clear understanding of our stream network. And what we're basically going to do through discovering the Strahler order is basically we're going to derive our river network. So let's go ahead and open this tool up. And as you can see, it's quite straightforward. All we need is the elevation DEM, which in my case is now going to be the fill DEM. And when it comes to the Strahler order, we're just going to basically save this to a new raster file. So I'm going to name that as stream order. And after that, you can just go ahead and run this tool. Yeah, now you can see that it actually generated a new raster called stream order, and the values basically vary, as you can see from here, 1 to 11. And it might not really be apparent what the stream order of each stream is supposed to be. And if I zoom just a little bit, you can start seeing that we're making some progress, because now you definitely can start seeing a massive river network. But this is something that we have to further clean up just a little bit and probably change its appearance so that we can interpret it in a way that it makes a bit more sense when it comes to its appearance and things like that. So the first thing that I'm going to do is I'm going to right click over here and go to properties, and I'm going to head over to symbology, because now I'm going to change its appearance. So when it comes to the render type, instead of single band gray, we can switch this to single band pseudo color. And from here, under mode, instead of continuous, we can go with an option like, let's say, equal interval. Following that, we can actually specify a number of classes. So just to be consistent maybe with what I see over here, that it's varying from 1 to 11, I'm just going to specify 10 or maybe 11 classes. Let's go with 11. So you can see that for each class, a color gets assigned, and these numbers are basically nothing other than Strahler order values or stream order values. So you can see if we happen to see a stream with its order value of 11, it's actually supposed to be quite a large stream compared to these other small streams which might have very low order values. And when it comes to the color ramp, you can actually go with anything that you like, but I think I might just go with this default color ramp. And under interpolation, you can see that currently it's set to be linear. I'm just going to select discrete from here, so that the colors will actually get assigned in a sort of a discrete manner to each stream order. And after that, you can just click apply and click OK. And if you expand this stream order, you can basically see the stream order categorization. So everything that's more than 10, which basically happen to be 11 in this case, correspond to relatively, well, larger streams that you can find in this DEM, with its order being higher than 10. Now, as you can see, there's actually a lot going on, especially when you think about maybe these streams with lower order. It's actually quite an extensive drainage network, but I might not really be interested in having such a detailed drainage network. I might need to cut something out. For example, maybe small streams with the stream order that are maybe less than 5 or less than 6. I might need to get rid of those. And one of the ways of doing that is simply by using something called the raster calculator, which you can access simply by heading over to raster, and right over here you can see the raster calculator. And a raster calculator basically allows you to do quite a number of computations pertaining to various rasters. And in this case, what I'm going to do is I'm just going to say that I would like to take my stream order raster, which is this one right over here. So if you double click, it gets added into this raster calculator expression. And I'm just going to specify that I would only like to have streams in my stream order raster where the order of the streams are greater than or equal to, I'll let you pick the number, let's say maybe 6. If it ends up being too weird, we can always go back and maybe make changes to this number. And this is basically the expression that we're after. After that, we have to specify an output layer. And I'm just going to save this to a file called, let's say, stream order greater than or equal to 6. And save. And after that, you can just give it a run and see how it looks. Yeah, so you can see the river network actually got trimmed down quite a lot. But if you want to visualize this properly, what you can do is you can actually go to properties and under render type, instead of single band gray, this time I'm going to pick paletted or unique values. And after that, let the color ramp be assigned to random colors. And if you click classify, you can see that we basically have 2 values in this raster. The values that correspond to 1 are basically the values that show the river network, and the values that correspond to 0 would be just the values that are, or areas outside of the river network. So what I can do is I can just double click over here and maybe pick a color that's more representative of the river network. And at the same time, I might be able to actually select something like white for this outside areas. And if you go to transparency, right over here, you can see that by default, it basically has some sort of a no data value assigned to it. And what I'm going to do is I'm just going to, if I come back to the symbology, I don't really need all of these areas where the pixel value is 0. I'm just only interested in the river network, which happens to be the pixels that has a value of 1. So I'm just going to head back to transparency and I'm just going to specify 0 over here. And when you do that, it'll actually consider the areas with the pixel value of 0 to be an area with no data. And that's totally fine with me. So with that setting, if I just go ahead and click apply and click OK, now you can start seeing actually the river network. But what I need to do is I probably might have to deactivate all of these other layers like the stream order, and with this you basically can start seeing the actual river network. And this is going to make it extremely easy for us to start delineating the catchment. And something you still have to keep in mind is that this river network is not really a vector file just yet. It's still a raster file. So I think before we move on to the next step, what we basically can do is we can spend a couple of minutes to, well, generate a river network that's made of polyline features, because dealing with vector files, especially for things like river networks, is way easier than dealing with the raster files like this. And to do that, you can basically use another tool called channel network and drainage basins, which also happens to be one of the tools under SAGA toolset. So when you search channel network, it should start to appear. So it's the second one right over here, channel network and drainage basins. So if you double click over here, you have to specify a couple of inputs. For example, the elevation in this case, it's supposed to be still your field DEM, this one. And the threshold, this basically refers to the same Strahler order that we just dealt with just a couple of minutes ago. And as you can remember, we selected a threshold of 6 and above. So I'm just going to put 6 right over here. And by using this tool, what we need to generate is basically the channels network. So to make things easier, what I'm going to do is I'm going to untick all of these because it can be a bit messy sometimes, the QGIS GUI. If I want to generate the junctions, I should use this one, drainage basins, this one, and then if I want to generate the channels, this is where I should be saving that file to. So let's just go ahead and save that to a file called channel network, and as you can see, it's basically going to create a shape file out of it. And after that, we can just hit run and see what happens. And after you click close, you can see that it just generated polyline type channel network. If I right click over here and go to attribute table, you can now see that this channel network shapefile is comprised of 1543 line feature objects. And along with that, you can see quite a number of fields as well. For example, if you're interested in knowing the streams with the highest order, what you can do is you can just basically double click over here, and that's going to sort everything from the lowest value to the highest value. And all you have to do is just select all the streams with maybe order number 6, and that should simply highlight that. Well, just because of the color, you probably might not be able to see them quite clearly over here, but all those selected streams are highlighted in yellow, as you can see right over here. So that's the way to generate this channel network shapefile. And now since we have such shapefile, things actually become quite easy when it comes to delineating watersheds and sub-catchments. So to delineate a watershed, I'm going to use another tool called Upslope Area, which also happens to be a tool that's packaged under this SAGA toolbox. And that's one of the tools where some of you guys have trouble to get it to work through no fault of any of you. It just happens to be that in certain versions, there happens to be a bug that's not corrected, which has actually been pointed out by a number of people. And unless you're using a later version, you probably might end up getting the same error message. And during this process, we're actually going to visit that error message, and I'm going to present to you the fix as well in case if you happen to encounter that problem. So it's all sorted. People have already figured out how to correct that. So in case if you happen to run into issues as you're using this upslope area tool that we're going to use just in a few minutes, don't get discouraged. We're going to figure it out together. All right, so as I told you guys, the name of the tool is Upslope Area. So if I just search Upslope Area, you can see that the tool gets opened up right over here. And what you need to run this tool is actually just a simple, a couple of entries. So you need a target X coordinate and a Y coordinate. And apart from that, you will need the elevation, and that's basically it. Now, if you're wondering what is this target X coordinate and Y coordinate is, if you think of a catchment or a watershed being like this, you can see that this is the boundary of the catchment. You can see that there's one point which can be considered as the mouth of the river or the outlet of the catchment. So all the rainfall that actually falls to basically any point of this catchment should eventually drain and come out of that particular point. And that's basically going to be the outlet of that catchment. And if somebody were to basically define a smaller sub-catchment, let's say pertaining to just this river, then its corresponding sub-catchment might look like this. You probably have to excuse my drawing skills. And all the water that basically falls in any part of this sub-catchment should eventually come out of this point. So if you're basically considering just this sub-catchment, then the corresponding outlet point is going to be this. But to get started, since we are considering this kind of a very large watershed, the corresponding outlet point for that is supposed to be this. So that's exactly what we're supposed to specify when we're using this upslope area tool by giving its X and Y coordinates. So coming back to my QGIS workspace, I'm actually interested in this river branch that's right over here. And the major outlet point that I'm going to be interested in, at least to get started, is going to be this point right here where it joins this incoming river. So I'm just going to activate my Strahler Order channel network like this and make sure that I grab the coordinates of this particular point. And you can see that as I move my mouse pointer, if you look at the bottom of the screen, you can see that the coordinates actually change. So one quick and easy way of getting the coordinates of any point is simply by placing and holding your mouse pointer, and if you have a pen and a paper handy, you can just basically note them down. That would be the most easiest and straightforward way of doing that. But we actually have more technically advanced ways of doing that as well. And with QGIS, you have the capability of just simply right-clicking over here. And if you just go ahead and select the corresponding coordinate reference system, which is this UTM zone 32 north, you can basically see a snapshot of those coordinates. So even if you move your mouse pointer on this window, it doesn't basically change the original coordinates, and it basically lets you copy them as well. So if you just go ahead and copy this, and now if you generate, open up your upslope area tool, and if you try to maybe paste it by, using Control V, you can see that the X and the Y coordinates basically got copied, but we are supposed to just put X coordinate over here, and the Y coordinate, I can basically cut it and paste it over here as well. And when it comes to the elevation, we can select the field DEM, that's our original elevation raster. And when it comes to the method, you can go with the deterministic 8. Now, if you're wondering what this deterministic 8 refers to, it's basically a method that's used to calculate the flow direction for each cell, and it's determined basically according to the steepest descent to one of its 8 neighboring cells, as you can see from the diagram on the screen. If you're interested in reading about it a bit more, You can just Google it and you'll be able to find plenty of information about this method. But for now, you can just take my word that it's a method of determining the flow direction. And after that, you can just go ahead and save this maybe to another file. And I'm going to name this as catchment large, because it's basically going to generate a large catchment. And just in a few minutes, as you can recall, the title of this video is generating multiple catchments or multiple sub-catchments. So after I generate this large catchment, I'm also going to tell you how to generate multiple sub-catchments. And those sub-catchments are definitely going to be smaller than this large catchment. So that's why I thought of naming this as maybe a large catchment. So after that, you can just click on save and you can run the tool. It's probably going to take a couple of seconds for it to fully run. And if you're using a recent version of QGIS, just like what I'm doing right over here, then chances are you might not really encounter any problems. And as you can see, what it did was it basically generated the watershed corresponding to my given outlet. And if I drag this channel network on top of this, well, or maybe drag it under the channel network, yeah, now you can quite clearly see how this catchment or how this watershed happens to be the watershed that's pertaining to this set of river branches. So you can see that all of these rivers are basically flowing in and eventually it's draining out from this outlet point. Pretty cool, isn't it? But if you happen to be one of those people who happen to use maybe a version of QGIS that's not really compatible with this upslope area, and you end up getting an error message when you try to run this upslope area tool, it most likely is this sort of an error where it basically fails to generate the layer, and you might have an error message that's along the lines of this. So after a few discussions back and forth in this thread and in a number of other discussion forums regarding this error as well, they have figured out that one of the files pertaining to this upslope area tool needs to be changed. And the name of that file is TA hydrology upslope area. And how do you find that file? Well, you would have to go to your C drive and you have to head over to program files. And from here, scroll down until you see your QGIS installation folder. In my case, it happens to be QGIS 3.34.10. In your case, if it happens to be any other version, you probably will be able to find that QGIS installation folder in your program files. So open that up. And one of the easiest ways of actually finding that file is simply by searching for it in this search box. So the name of that file is TA_hydrology_upslope_area. And you probably would be able to find the file appearing just like this. After that, you can just go ahead and double click on it. And that's going to open up a text file like this. And after that, the only thing that you have to do to correct this upslope area tool is you have to add the pipe symbol, which is basically a vertical line. And after that, add the number 4. And then you just have to go ahead and save this change. Now, when you save this change, depending on the administrative privileges of the PC that you're working, you may or may not be able to do an on-the-spot change. Now, sometimes it might actually not let you save any changes because you are in the program files folder, and sometimes it's not that easy to make changes if you really don't have any admin privileges. So what I can recommend is that you just create a copy of this file, maybe in one of your working folders in another drive. You make this change. After that, you head back to the place where you found that file and you try to replace it. And that actually worked for me without any problems. So somehow the gist is that you have to make sure that you add this pipe symbol and number 4 right next to the first line, which is upslope area, and make sure you don't keep any spaces. And after that, if you try to run back this upslope area tool by just specifying the coordinates and the elevation file and the flow direction method, it just should run without any problem. So that's basically the fix that I want to tell you guys, in case if you happen to come across the same issue that many people have faced by not being able to correctly run this upslope area tool. So guys, moving on, you can see that we managed to generate this catchment large like this, and still this is actually a raster. So if you want to convert this into a polygon, you can basically go to raster and select conversion, and you can use this polygonize function to basically convert the raster into a vector. So let's just go ahead and do that. So my input layer is basically going to be this catchment large, and I'm just going to save this to a file called catchment large polygon and save, and you can just basically run that. Yeah, and now you can see that we managed to basically generate a polygon out of the catchment. And now we can do things like calculate the catchment area and all sorts of stuff that we can do usually when we have polygon objects. So if you right click over here and go to attribute table, you can see that we basically don't have much information over here, but it's still a single polygon object, as you can see right over here. Alright, moving on. Now I'm going to actually generate multiple watersheds. You can see that we just have one single large sub-catchment over here, and now we'll see in case if I want to generate multiple watersheds how I can do that. And there are actually a number of ways of doing that, but I'm trying to make use of a method that's not too complicated, but at the same time it's not too repetitive as well. So what I mean by that is that I'm still going to rely on this upslope area tool, but only this time I'm not going to run the upslope area each time for each sub-catchment, but what I'm going to do is I'm going to generate a bunch of X and Y coordinates that's corresponding to all the outlet points that I would like to define. If you can recall the image that I showed you guys, we can define outlet points depending on how we would like to have our sub-catchments arranged. So that's what I'm going to do next. And to do that, instead of copying the coordinates of each outlet point manually, I think it would be much easier for us to generate maybe a point shapefile and place those points in my desired outlet locations. Using geometry calculator of QGIS, we can just basically calculate the X and Y coordinates and maybe save the X and Y coordinates of all the points just in one go, and we can then start using that in this upslope area tool. So to do that, to create a new point shapefile, what I'm going to do is I'm going to navigate into my working folder, which is this QGIS multiple watershed delineation file. I'm going to right click over here and going to create a new shapefile, and it's going to be outlets, plural, because we are going to define more than one outlet, and the geometry type is going to be point, and quite important, the coordinate reference system is going to be UTM zone 32 north as well. And after that, you can just go ahead and click OK. You can find it right over here, double click to bring it over to your layers panel, and you can right click and put it in to editable mode. And after that, if you select this add point feature button, you can basically start adding point features. So I think what I'm going to do is, just for consistency, I'm going to add another point at the outlet location which we used to generate this large watershed as well. So I'm just going to make name it as number 1, and I'm going to generate separate subcatchments at, well, this point and this point, but it's quite important to make sure that we select the corresponding grid cell, and that's where this original Strahler Order stream network can be quite useful. So I'm just going to move this up to here, and from here I can quite simply see what is the corresponding pixel. So I'm just going to pick this one, we'll have to select the outlets file again. And after that, I'm going to start adding points again simply by selecting this add point feature. And this is number 2. And there's going to be another point feature to accommodate this river branch that's supposed to join into this main river around here. I'm going to add that as well, which is point number 3. And I'm going to add 2 more sub-catchments to accommodate, let's say, this river branch that's flowing in at this location. That's number 4. And let's define a sub-catchment for this branch as well, which is number 5. And I'm just going to generate 1 large sub-catchment for this part of the river branch as well. And I'm just going to name it as 6. I think that should be sufficient enough just for the purpose of this tutorial. And after that, you can just select this button to basically save your edits. And you can see at each point, well, at each outlet, we have a point feature that would be able to record the X and Y coordinates of each point. And the way to record that X and Y coordinates is simply by heading over to the attribute table of this outlets layer, and you can head over to, well, right here you can see the 6 different points. And if you head over to the open field calculator button, you would be able to specify a new field called X coordinate. And the way to extract the X coordinate is, if you were to just simply type X, it probably might not return you a value that makes sense. But in QGIS, according to the QGIS syntax, if you want to retrieve the X coordinate, you just have to add a $sign for whatever reason. And so we'll just go ahead and add a $sign. And after that, if you click OK, it's going to create a new field called Xcoord. And for each point, it's going to record the corresponding X position of that point. And similarly, we would need the Y position as well. So just going to create another field called Ycoord. And if I add the $sign over here and specify Y, it's supposed to return the Y coordinate of each point as well. All right, now what I can do is I can try to open up the upslope area, but I'm going to make sure that I don't really double click over here, because if I double click, I probably have to run this tool 6 different times manually, and that's tedious. Instead, what I can do is I can right click over here, and instead of executing, I can execute this as a batch process. And that's where it becomes a powerful tool, where I would be able to enter this corresponding information in 6 different lines or 6 different rows corresponding to the 6 different sub-catchment outlet points. And after that, it'll actually generate 6 different sub-catchments corresponding to these outlets. So that's the idea. Now, if you find it easier to copy all of this maybe into another separate file, like an Excel file or something like that, you could actually do that simply by selecting this entire thing, and you can just hit Control-C and you can open up your text file or notepad file, and then you can just paste the entire thing, and then you can work it directly from there. At the end of the day, what you need to do is you have to make space for 6 different items. So that's supposed to be 1 more. And some of these things will actually get the same property. For example, the method is going to be deterministic 8 for all 6 points. And anything else? Yeah, the elevation, it's supposed to be the field DEM as well. And what might be tedious is getting them copied one by one in each row. Well, I would say that it's actually much better than running the tool separately 6 times. So I'm just going to do it manually. Might take less than just a minute. Copy the coordinates of the first point like this and move on to the second point. All right, after that, all you have to do is basically specify your output file names, which is something that we probably might have to do manually as well. So I'm just going to create maybe a new folder called sub-catchments. And after that, I'm just going to incrementally use 1 to 6 and have the name a format like this, catchment 1. And I probably might be able to just copy and paste all of this like this and just change the name to be catchment 2, catchment 3, 4, 5, and 6. And that looks pretty good. After that, you can just go ahead and run this. Well, before that, you can click on load layers on completion so that after it completes, it'll be added to our workspace. So go ahead and click run. Yeah, now you can see that it's iteratively running for generating all 6 catchments, which is the fun part because now we don't really have to do or use the upslope area tool manually for each subcatchment. It just basically runs by itself. Right, you can see that it got executed in less than a minute. So go ahead and close this, and now you can see all 5 catchments got generated, but it might not be visible to you just yet just because of the color. Now if I go ahead and assign a separate color for each subcatchment, for example, let's say I'm going to select unique values over here, classify, and maybe use red for this one. And for catchment 2, let's say if I were to use another random color like this. And for catchment 3, and do that for catchment 4, and do that for catchment 5 as well. So as you can see, all the subcatchments got generated according to how we defined it based on the specification of the outlet points. However, you have to still keep in mind that these are basically rasters, so you don't really have much control over it. So what I recommend is that we can just go ahead and generate or create polygons out of each subcatchment, just like what we did before. But again, we don't really have to do it manually one by one. You can use the same batch processing method to basically generate subcatchments in polygon form. So what I'm going to do is I'm going to search for the tool Polygonize, basically the same tool that we used previously. But when you access it through the processing toolbox, you can right click and use it for batch processing. And that's what I'm going to do over here. Just increase this to 6 items. And after that, we can select catchment 1, catchment 2, catchment 3, catchment 4, catchment 5, and finally catchment 6. And when it comes to the output, well, what we can do is we can specify, you can have it either as a geo package, or if you want to have it as an S3 shapefile, you can do that as well. I think I'm just going to go with an S3 shapefile. And the file name, I'm just going to still specify maybe cat1 and then incrementally go until cat6. This is supposed to be cat2, cat3, 4, 5, and finally cat6. And after that, we can load those layers on completion as well. Click run. And after that, just to make things clear, I'm going to get rid of these 6 catchments which are rasters because we don't really need them anymore. And that should be fine. So you can see that we basically managed to generate 6 different catchments like this. But there's still one issue, because if you actually deactivate, let's say the area of the catchment 1 is basically still this large catchment and everything else is basically drawn on top of that. However, what we should be doing is we should be able to merge all of these together, just so that each of these piece of polygon will be its own sort of sub-catchment. And you can simply do that by using the merge tool. So if you just try to search for merge over here, and you probably would be able to find that tool, which is this merge vector layers. Double click, and from here you can basically select all the layers that you would like to merge together. And in our case, that's going to be catchment 1 to 6. Click OK. And after that, we can maybe create a new file called sub-catchments merged. And that's going to be an history shapefile as well. And after that, you can just go ahead and click run. And with that, you would be able to get this kind of a merged sub-catchments layer. And if you take the select tool, we'll select features. And now if you make sure you select that corresponding layer, and if you try to do individual selections, now you can basically go ahead and select sub-catchments like this, which is actually what we were after from the beginning. So to deselect everything, you can just click on this button as well, and which means I no longer need these 6 different sub-catchment pieces as well. So we can just go ahead and select remove layer and get rid of those 6 as well. And at the same time, I probably might be able to cut down parts of this channel network that are not necessarily important for me as well. And you can simply do that since we have this large catchment polygon still with us, which is this one. I can actually make use of the extent of that large catchment polygon to kind of cut out this channel network and basically get rid of the channel network of this outside area. And I could simply do that by performing a clip operation. I can go to vector, and under geoprocessing, you would be able to find the tool which is called clip. And what I'm going to clip right now is my channel network, and I'm going to overlay it with the extent of the large catchment polygon. So in both cases, you can see that we are dealing with the same coordinate reference system, which is going to be quite important, because if you have different coordinate reference systems, this is not going to work, because even though it might appear to be at the same location visually, actually it's not at the same place, so it won't be able to perform a clip operation. So I'm going to save this to a new file called river network clipped, and you can run this tool as well. So after that, you can basically deactivate this channel network, and you can simply deactivate all the rest of it as well. Well, I think I forgot to save this outlets file. You just can go ahead and save it as well. And now we no longer need any of these supporting files that we previously needed. And now it just becomes a matter of doing the final touches. Maybe if you want to change the color of this line, you can change this to be something along the lines of blue like this. And if you want to maybe increase the stroke width to about 0.5, you could do that as well. And you can see beautifully flows from around these highland regions and flows through this specified outlet point. And at the same time, if you want to specify separate colors for your sub-catchments, you can right click and, well, maybe have a look at the attribute table first. So you can see what you have is basically these three fields, which may or may not be necessary at this point of time, but that's fine. So if you go to properties and under symbology, if you go to categorized, and from here under value, if you just go with the layer name, and if you classify, you can see that since we selected random colors for the color ramp, well, random colors would get assigned to each of these different sub-catchments. And if you click apply and click OK, now you can basically see this yellow color refers to this catchment, and the red color would be catchment 6, and so on. And finally, if you would like to generate things like areas of the sub-catchment, you could simply do that as well by opening up the attribute table, and similar to what we did before, you can head over to open field calculator, and you can simply create a new field called area, and output field type, you can select that to be a decimal number. And to calculate the area, all you have to do is just put a $sign and type area, and that should calculate the area in square meters. So right over here in the preview, you can see what the area is for catchment 1 in square meters. However, if you would like to do a unit conversion to maybe change that to square kilometers, for example, let's say for area, you can just perform the corresponding unit conversion. So to convert this to square kilometers, I would have to divide this by 10 to the power 6. And depending on how many decimal points you need, you can actually adjust the precision over here. Let's say if you just want to have maybe 2 decimal points, you can add the precision to be 2. And after that, if you click OK, you can see that the corresponding areas got calculated. So during the geoprocessing operations, you probably might notice that, for example, for this catchment 3, in addition to the actual catchment 3, 2 more other sort of empty polygons got generated as well. And you can simply get rid of those by selecting them, and you can just go ahead and delete the selected features, because it's basically an empty feature or an empty record. You can see there's actually no area defined for those features. So we got rid of one, and to get rid of all of those empty records, what I can do is I can just hold down Control button and select all of them all together, and after that you can just delete these selected features. And just like that, we managed to generate the corresponding areas for each sub-catchment as well. And after that, to save the edits, you can just simply click on this button, and that'll save all the edits. Alright guys, so that actually brings us to the end of this tutorial. We covered quite a lot of things. We addressed some of the very well-known bugs, and in case if you happen to be in the group that happened to experience those bugs, then we actually presented you with a potential solution as well. And this is a comprehensive tutorial, I would say. If you do have any questions, don't forget to add a comment down below. And if you appreciate the work that we're doing, you can always show your support by hitting that like button. And I'll see you guys again with another tutorial soon.